Hey kids, sorry for deserting you for 2 days. Believe me, I would rather be with you and teaching than at the meetings I've been at. So hopefully you have finished your quiz. I know it says 15 minutes here, but I asked the sub to give you 20 minutes, so I hope you appreciated it, and I don't imagine that you needed it each time. And hopefully you have picked up the graded quiz 1. I asked the sub to have those out for you. We will be doing a reassessment on quiz 1 next week, and I'll let you know on Monday or post it when the reassessment is. But remember, you need to do corrections to your current quiz. So find a peer, come ask me, look at your homework. From that past week, all those problems were either identical or just matched to previous homework questions that you had during our factoring week. Okay, so to go on to notes now, you just took the quiz on adding, subtracting, multiplying, and dividing, and you're going to need some of those skills to do rational equations, not expressions, equations. So we are going to solve, which means we're actually going to find values for x to plug in here. Right? If I plug in an x here, that same x here, 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 and here, I want to know what x's will create equality on the left side and the right side. Since I'm trying to solve and find x's to plug in, the first thing I have to look at is what are bad x's. Remember, what x's can't I plug in no matter what? And I hope you remember from Unit 1 when we were dealing with functions and finding domain, and recall that the domain that you're supposed to assume is all real numbers unless you have domain busters. Well, hello, I don't care about this x in the numerator, but I know 2 can't go there. And what can't go there? -3, correct. I don't know what can't go here yet because I can't see what makes this 0, so guess what I have to do to this? That's right, the good F word. You need to factor this and find out if there are any additional bad x's. So that is step 1. Step 1 is factor everything. Factor every numerator and every denominator. Now our numerators and denominators are all prime except for that last denominator. So there's me writing it in factored form. Now take each domain and set it each denominator and set it equal to 0 to see what numbers need to be kicked out of the domain, if any. I'm not saying that just because you have a denominator you'll have a bad x. Now, I don't actually set these denominators equal to 0 because I can just figure them out, right? I can just visually know that 2 would be bad here, -3 would be bad here, 2 would be bad here, -3 would be bad here, and yes, that's a coincidence. That's me making a math problem easy, that the bad x's on the left side are the same as the bad x's on the right side. But when you get up and math gets more complicated, you're going to get more complicated expressions. So I will actually set each denominator equal to 0. And I will solve for x's. And then I will make a list. If all of these x's create zero in the denominator, then my domain for my problem is going to be x is not allowed to be 2, x is not allowed to be -3, x is not allowed to be 2 or -3, which is what, and of course I only have to write these things down once. So my domain for my problem up here, what is the domain? All real numbers, but x cannot equal 2 and x cannot equal -3. And that's going to be important for the end of the problem. So I'm not always going to ask you or prompt you for the domain, but if you don't think about the domain and domain busters, it could come back to hurt you at the end. So after I've determined my bad x's, now I'm going to find the least common multiple, just like we did with adding and subtracting. my least common multiple, or you can think of this again as a common denominator. After I find that, I'm going to multiply each term on both sides of the equation by that least common multiple, or that common denominator. Now remember, since I have an equation, I don't have to multiply the top and bottom of a fraction like I did with rational expressions, right? I can't take a fraction and just multiply the bottom by 2. I have to multiply the top and bottom by 2. But the minute I have an equation, I have a lot of power. I can change each fraction. Change it. I don't have to multiply the denominator. I can change each fraction as long as I change by the same amount on both sides. Here's my heart of the equal sign. Right? If I have an equation, I don't have to multiply by that 1. I don't have to do the top and bottom of the fraction. Now, when I'm done multiplying each term and simplifying, my goal is to get rid of all those denominators. So, if I'm done with this next step and all my denominators are not gone, I've done something wrong. So notice I can cancel that x minus 2 denominator with a factor of x minus 2 in the numerator. X plus 3 in the second fraction can cancel with the matching factor in the second numerator. 2 factors in the denominator matched with 2 factors in the numerator. All my denominators were gone. And then notice that I multiplied the x times this remaining x to get x squared plus 3x plus 2x minus 4, and there was nothing to distribute the 10 to. Now I'm back to Algebra 1. And my Algebra 1 is good and fast. I know that the process here is to get everybody equal to 0 since I have a squared and linear terms. I cannot just isolate x, I have to collect x. And I get -7 or 2. So again, my Algebra 1 has to be fast, right? This is x squared plus 5x. This is minus 4. Bring the 10 over to get minus 14 is equal to 0. Mad minute time. This is x plus 7, or x minus 2 is equal to 0, and that's why I got the solutions -7 or 2. If you think you are done here with 2 solutions, these 2 solutions are the solution of this quadratic. But hello, is this quadratic the problem I started with? No. I need to take both of these solutions back to the very original problem. What was the original problem? The original problem was x over that same x minus 2 plus 2 over that same x plus 3 is supposed to be equal to 10 over, factored form of that quadratic was x minus 2 and x plus 3. So I need to check these. Can you put 2 in for x? Well, sure, you can put 2 into this box, and you can put 2 into this box, and you can put 2 into this box. But you cannot put 2 here. You cannot put 2 here. And if you cannot put 2 into every box, then 2 is your extraneous solution. Now let's check just to see if -7 creates equality. So I already know I can't put 2 in, or I create division by 0. But can I put -7 in? What do I get? I'm going to write my answer. I'm going to go up here since I've run out of room. negative 7 on top of negative 7 minus 2 is negative 9, plus 2 over negative 4. Is that equal to 10 over negative 9 times negative 4? So what do I have here? This is positive 7/9 minus a half, but how do I write a half with 9 as a denominator? Oh, I can't, right? I'm going to have to write that as with a denominator of 18, right? So I'm going to make this 9 over 18, and I'm going to make this 14 over 18. Is that equal to 10 over 36? So 14 minus 9 is what? 5 over 18. Is that the same as 10 over 36? Right, multiply both of these by 2, and yes, they are the same. So negative 7 is the correct solution, and 2 is extraneous, because plugging 2 into this quadratic, that's fine, but that's not my original problem. This is my original problem. And plugging negative 2 in here creates division by 0, so that's why I had to eliminate 2. Now, you do not have to check to make sure negative 7 is right. You should, but you don't have to. You have to eliminate 2. And you have to show me that you originally get 2 and that you have discarded. So the final answer to this problem is x is equal to 7 and a crossed out x is equal to 2. So let's do another example. So for this one, now again, this is pretty easy, right? If you factor this, you figure out that the factors are x plus 2 and x minus 5. So I say to myself, the domain is x cannot equal negative 2 or 5. Then I go about my business. I find my common denominator, and my common denominator is x plus 2 times x plus 5, and I multiply. And yes, you have to write this down because you have to communicate to your grader what you're doing. So bam, 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 bam. And I'm left with x times x minus 5 plus 7 times x plus 2 equal to 14. This is my Algebra 1 piece. This goes fast. Subtract 14 from both sides. Pull out the greatest common factor. Set each equal to 0. And note that x is equal to 0 or x is equal to negative 2. But now I need to check back here at my domain and say, oops, guess what? X is not allowed to be negative 2. So my final answer is 0. And if you go back to the top and find out if you put 0 here, 0 over 2 is 0 plus 7 over negative 5 to 0. Is that equal to 14 over negative 10? Oh, I forgot that I wrote these down. Ah. There you go. X is equal to 0. Now, let's pretend, this did not happen, but let's pretend that when I had done all this algebra, I had gotten solutions of both negative 2 and 5. Right? Instead of kicking out one solution, how many would I have kicked out? Both. And then your final answer would have been, there are no valid solutions. How about if you had, and again, this didn't happen, but let's pretend you did all of this algebra, blah, da, 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 all this algebra, blah, da, 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 and you ended up with no x's. You got 0 equals 0. Do you remember what that would mean? That means besides the bad x's, you have infinite solutions. Just like you did with systems of equations. No, you don't call this, we don't really use that same IB language with that kind of system. Again, another way to get no, what if all your x's had dropped out, but you got something like 0 equals 7, or 0 equals negative 2, or 6 is equal to 7. That's another way to get no solutions. So again, none of these situations happened, right? None of these things happened. They did not happen with our original problem. I'm just saying that you might get some problems where this happens. Alright, here's the next one. If it makes you feel better, put this over 1. Hopefully you can figure out that your domain is x cannot equal 1 or negative 2. And then my least common multiple, or my common denominator, is the product x minus 1 times x plus 2. So I'm going to multiply I'm going to get out my Terminator pen. Bam, 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 oh, there's nothing to cancel here. That's okay, my denominator is just 1, so I'm not worried. Remember, my goal was to get rid of all denominators. So what do I have left? 3x plus 2 times x plus 2 plus 2x minus 4 times x minus 1 is equal to 5 times x minus 1 times x plus 2. So again, your algebra's got to be a little fast here, right? 3x squared, what is that, 2? X plus 2. So 3x squared, 6x plus 2x is 8x, plus 4, plus 2x squared, minus 2 minus 4 is minus 6x, plus 4 is equal to 5 times x squared plus x minus 2. So what do I have here? 6x squared plus 2x plus 8 is equal to 5x squared plus 5x minus 10. Therefore, x squared minus 3x plus 18 equals 0. Therefore, x minus 6 and x plus 3 is equal to 0, meaning that the solution to that quadratic is x equals 6 or negative 3. Now I check. Up here, do you have an oops? No. So how many answers do I have? Solutions. I have 2 valid solutions. You can plug, what that means is you can plug both 6 into all of those x's and negative 3 and get a valid solution. Alright, let's try one. Let's try another one. Here's another one. So if notice I have 3 denominators, only one of them factors. I don't like this though. I am going to write this problem this way. I'm going to change this minus to a plus because I factored a negative 1 out of the denominator and turned the x squared positive and the 1 negative. I did that because now I recognize x squared minus 1 is x minus 1 times x plus 1, which now means that I can see my domain, x cannot equal 1 or negative 1. And my common denominator, or my least common multiple, is x minus 1 times x plus 1. So that means I'm going to go up here and multiply times x minus 1, x plus 1. Get out my Terminator pen. Bam! Bam! And remember, this is really now this. So, bam! Bam! And then x plus 1 and x plus 1, which leaves me with x times x plus 1 from the first fraction. Remember, that minus got turned to a plus. 2 times nothing, because both factors canceled out, and is equal to x times x minus 1. So I have x squared plus x plus 2 is equal to 8x minus x. X squared minus 7x, oops, 8x minus 8. X squared minus 7x plus 10 is equal to 0. Mad minute time, x minus 5 and x minus 2 is equal to 0. Therefore, the solution to that quadratic is x is equal to 5 or 2. Check. Are any of them bad x's? Nope. Therefore, the solution to my original problem is both 5 and 2. And that's it. I hope you have a great weekend.